On today's Maker Mashup, we're talking about the LayerFused X301 DIY 3D printer. So today's Maker Mashup is a little bit of a preview to the LayerFused X301 3D printer. Now, if you've been following the channel for a while, you know that we already have the C201, which is a DIY 3D printer series that you can watch and build your own 3D printer. And I've got a link to that right at the top here if you haven't seen that before. In today's video, what we're going to be talking about is this, which is the X301 printer that I'm very excited to announce. So what this printer is another one of our printers that's going to be a DIY series. So you'll be able to follow along step by step and learn how to build this 3D printer. But today's video, I'm excited to really announce this and go over some of the features and functionality in it. We're going to be starting the 3D printer series on how to build this in a few weeks. But until then, I wanted to get this teaser video out so that way you could see what this printer is capable of and how you can build one of your own in the coming weeks. So let's talk about the mechanical specs of this printer to start things off. This is a 300 by 300 build plate right here. And with that, it has a total of 330 to 340 millimeters of height, so Z-axis there, that you are able to make some really large prints. This was a Spanner Hands rocket that I put together, and that's also a vase. Very quick prints on the printer. Matter of fact, these are knocked out in about 2 hours total to get these prints out the door. And that is due to the volcano nozzle that is on there. Because that longer melt zone, we're able to run this printer at higher speeds. And as you can see, these are some pretty decent prints for printing at roughly 150 millimeters a second. The printer uses all linear rails for both the X, Y, and Z. Being a CoreXY, the head moves, so the bed goes up and down, so there's none of that bed slinging that you find with a typical Cartesian printer. Now, some of the other mechanical things that are really good call outs here is that there's 2 steppers for the X and Y, just like a traditional printer, and 2 steppers down here in the bottom case for the Z axis. Now, they're driven independently by independent Z-steppers, but we're using an SKR version 1.4, which has pinouts for dual Zs right in there. Other mechanical features of this printer is that it's mostly all aluminum extrusion or aluminum bonding plates. You can see here, looking at the printer, that there's aluminum bonding plates here and at all the bases. Only at the top here where we have the 3D printed parts to have the CoreXY idlers here and here. Those idlers are in 3D printed parts, and then these idlers are here as well. Now, you could take these models once it's available and get them printed in metal if you wanted to, but in our testing so far, there's been very little impact or difference, none at all, on using 3D printed parts for this. So it's an excellent opportunity to use some 3D printed parts where it's really needed to build your own, and then use aluminum in other places to make the printer stronger. Now, some of the other cool mechanical aspects of this printer that you'll notice is that the entire front of this printer is open, and that's really cool, and that's one of the things that we wanted to do with the design. When you look at other CoreXY printers like the Hypercube, you find that it's a cube and it's a little bit more difficult to get your prints off of. This allows you really that free access to get to your print after something is done, and with the larger build volume, it's really designed to be able to print some larger items. So if you saw our C201 series and you looked at it and said, how do I make it bigger? Which I received a lot of emails about people that wanted to make a larger printer. This is really your best bet for a larger format printer. This one with the 300 by 300 build plate is bigger or on par with printers like the CR10, but the nice thing about the CoreXY is that you're going to find less vibrations and higher speeds, being able to not have a bed that's moving back and forth. So the printer design overall really allows for higher quality prints and higher printing speeds. Now, like I said, this printer printed this one at 150 millimeters a second. Now, you're not going to actually get that sustained speed in there, but for items like the larger area here, you can see that the printer was able to go ahead and print at that higher speed and still maintain a relatively decent amount of quality. And I talk about in some of my other videos about trading off speed and quality. This printer really gives you a little bit of both, so you can get a higher speed and you can have some higher quality. You're able to extrude a lot more filament because we use that volcano nozzle on here. And that'll all be part of the DIY series. We'll go through step by step how to start building the frame and get that all together. And we'll have a full bill of materials as well, so that way you can go through step by step, build this yourself. We're also in the process right now of talking to different vendors about possibly offering this as a complete kit. Everything in this kit was built from the ground up, so therefore we own the rights to all of the different models in here. So it's really a new printer design from the start. So the advantage here is that instead of finding a bunch of models on Thingiverse like the C201, this printer, all the models will be in one spot. Okay, so I raised the bed up here and I want to talk about some of the items down below here, which is one of the cool things I like about this printer. I also want to take a second to give credit here. This is not entirely my own design. Nick Huggart, he's a friend of mine. We've been working on this printer for about a year now, and this is really the third prototype and really close to the final design that we will be moving forward with. This is 20 by 80 aluminum extrusion. Now this 20 by 80 aluminum extrusion allows you to put all of the electronics inside the bottom here. Now I've got some plexiglass that I've put here, smoke colored, and eventually I'll have a plate that will be cut exactly for this. But in the meantime, I had some old smoke colored plexiglass from plexiglass, not plexiglass, from another project. So I went ahead and cut that up and used that for the top there. So getting back to this here, one of the options that you've got with this printer is that this base is larger, so it allows you to enclose all of your electronics. A lot of DIY 3D printer designs have the power supply hanging off the back. Even production printers like the Ender and just a lot of different printers all have the power supply outside. Even the Prusa. This design, with a little bit of added material, which is the 2080 extrusion, you've got a nice enclosure down here for all of your electronics, and there's plenty of room. I've got dual power supplies in here, so you can run 24 volts for your heat bed, or you can run AC for your heat bed, and then 12 volts for your nozzle. It's really up to you how you want to power this, but 2 full power supplies will fit in here. Now, the way I've got this set up, they're both 24s, but one is a 400 watt and the other one is a 360 watt. This 440, I believe it is, watt power supply is adequate for the bed, and then another one here is 330. Now, why did I go with 2 power supplies? Really good question, and the answer is because these power supplies run with the fan off by default. So this printer is relatively silent every time you turn it on. So when you turn it on, the fans aren't going in the power supply because they only kick on when the printer's heating up. So this printer can be left on in your shop, and it's not very distracting while you're getting your models ready and everything else. You've got this 2080 area here to hold 2 full power supplies. Now in this version here, I've got the SKR version 1.4 turbo. Now, when we talk about the electronics in here, you'll notice there's no end stop switches. This will have the TMC 2209s, and those 2209s are gonna do the sensorless homing on the X and Y. There is a mechanical end stop, but I'm gonna be replacing this with a optical end stop for the Z axis. Now there's 2209s on here, but to save cost also, I have 2225s, which have the same current rating as a 2209, except they're a lot cheaper. They still are silent, and you're not gonna hear anything on the extruder, or you're not gonna hear anything as part of the Z axis moving. But the nice thing is that those 2225s are cheaper. So there's a mix of TMC drivers in this, and I'll talk about that more when we work on the build series itself. So what else does this printer have that's a really cool feature? Well, you might notice these little black pieces that are sticking up here. Now, what these black pieces are actually neopixels. And what the neopixels allow you to do is all of those go back to the SKR version 1.4 Turbo, which has these neopixels built into the board. So with a little bit of soldering, this and the other side there are lights that light up when the printer is building. Now, the really cool thing about this is that unlike a lot of other designs that you find for neopixels and that, it is not a bar, and I've created a video on how to put a bar on your 2020 extrusion to make that work. But the really cool thing is in the printer design, there's either models for doing this with neopixels so you can light your print bed, or you can do it without it completely if you don't want to deal with the neopixels. It removes this little tower there for the pixels itself. So that's a really cool part of the design that I like, because one of the things is that if you run your 3D printers at night, you're either leaving your shop lights on or you have some other sort of lighting. This is lighting right in the printer to keep an eye on your 3D prints. So one of the other things that's different with this printer is you notice there's no springs here. These are silicone mounts for the heat bed. The silicone mounts are very, very sturdy and very stable. Now, I know you're not going to believe this, but since I put this printer together, once it's put together, once your bed is level the first time, I have not leveled my bed since. It has been a one-time leveling situation. Now, how is that possible? First, this printer, very exact. You've got linear rails, so there's not a lot of movement there. There's no movement on any of it. The whole printer shakes and it's really the table here that's shaking. So this goes back to the same spot every time. And the nice part about that is I don't have to level the print bed. So while there's no design in this carriage here for a BL Touch, at this point, I don't see a need for one because my 3D print bed is always level. It stays level. And that's one of the things that I like about this printer. It is designed to be a workhorse. I turn a print on, send it to the printer. I don't even have to watch the first layer. It just prints and prints and prints. Start the next print, just goes. Very few failures do I have on the first layer or any other layer after that. It's really a solid workhorse printer, and that is one of the reasons why we built this, is so that way it was a printer that printed reliably all the time. So let's talk about some of the performance. Now, when we look at the performance, and I'm reading my notes here, the XY resolution has 1.8 degree steppers in here, which gives you 12.5 microns of precision with these steppers in here and these GT2 belts. And then when you look at the Z axis, this is a 2mm screw. It is not your standard 8mm that you find. By putting a 2mm screw in here, you got a 0.625 micron precision on your Z axis here. Now, what does that mean? It means that your Z layers can be very, very thin, and it can go ahead and print that reliably every time. Now, when I have this benchy here and I look at this benchy, this is an absolutely fabulous benchy that this printer printed. Now, why is it that way? Because it prints all of these layers the same way every time. I don't find a lot of banding issues. I don't find any issues unless it's speed related, in the sense that this print head is moving around the platform so quickly. With that extra melt zone in there, it really, really does make a very high performance printer and allows you to knock prints out pretty quickly. This particular build has case hardened, and for the actual build, I'm gonna be printing these in carbon fiber filament. So when we actually do the videos for this, I'll have all carbon fiber for this, making this even stronger. So let's talk about the carriage design for a little bit here. The carriage here is very straightforward and simple. It's just got a V6 nozzle, but the nice thing about this carriage design is it's completely open. Now, when you look at a Hypercube or an Ender 5 or a lot of other cube-based printers, the problem that you have is that as the print head comes towards the front, you're limited by the area that's inside the design. Not with this printer. With this printer, you've got this open area and it's very strong. There's no flexing here when this printer's printing or when it's idle. The nice thing about this is that because you have this open area here, you could have a fan sticking out the front, or you can get any sort of nozzle or extruder that you want to put on it, you simply have to attach the carriage plate here, which is an open source design. You attach the carriage plate, and then you can mount virtually any sort of extruder to the end of this. This is set up currently as a direct drive unit. Now it only has a pancake stepper here, so we reduce the weight with the pancake stepper. And the design also has the pancake stepper and the extruder putting the weight distributed right over the linear rail. So there's no twist either way for this, only the motion back and forth. And to date, even at 150 millimeter a second print speeds, again, not going to reach that in a lot of cases, but with that, I'm not seeing any sort of artifacts caused by that extra weight there. So this is a very lightweight carriage. It works really well. There's blower fans on both of those. They're both controlled through the main board. One of them's on all the time, but I plan on putting that into the second extruder because we only run one extruder, and making that fan turn on when the printer heats up, not when it's idle. So idle, this printer will be pretty silent all the time. Another thing that we did here is that the footprint of this printer is a 440 by 400 footprint, which means it's a very small footprint compared to other printers like the Hypercube, yet it still has the same build volume and it's got a more open front to it. So what it really gives you the ability is if you want to put this on a lack and enclose it, like you've seen many different 3D printers that use a lack table from IKEA for an enclosure, this printer will fit on it. Now, it's not going to fit height-wise, but the nice thing is it does fit on this, and you would be able to make some modifications to make this printer fit. It's really a great way to enclose your printer in existing resources that are already out there for making printer enclosures. So I've turned the printer around now, and I want to talk about the back of the printer. That's right, I want to talk about the back of the printer, the part that nobody really sees. To give you an example of the type of work that we put into this printer, all you have to do is look at the back of this printer. You can see we have a grill back there. Now, those black parts that you saw on the power supply earlier vent the power supply air to the back of the printer and then through those vents. The nice thing about that is that, unlike a lot of other printers in the marketplace, this printer is enclosed and you've got that air blowing out the back, and it's pleasant to look at. The other things that we've done here, obviously there's a panel here for the power. That's all in place. You'll see there that there's a USB port on the back, so you can hook up your printer or Octoprint, whatever you want to do there. And then what we've also done here as part of this is that unlike a lot of these wiring looms, we've gone and reached out and purchased from Misumi cabling that is got all the connections necessary to route it to the carriage here. So what we've got there is a nice clean look, even from the wiring in the back of the printer. What we've also got here, there's a little tower, and that little tower there holds the cords out of the way from getting into the belts. So really good design there that allows you to have the belts in the carriage moving around and nothing's going to get caught up there. Now on the other side there, you'll also see this blue tube here, which is just a Bowden tube. That blue tube there is just routing the filament up to the geared extruder up here on the carriage. So it's nice that it's very easy to get at there. The side has the a spool holder there, and then the filament just goes right into that little fitting there. All those parts over there 3D printed, and then that brings it over to the carriage. But I wanted to show the back of the printer because most people don't think of that, but when we did the design on this, we went the extra mile. We wanted to create a printer that was aesthetically pleasing in addition to being fully functional. So that's going to cover all of the teaser video here. Like I said, we're going to be working on building this printer and starting these videos in the coming weeks. I figure we're about 3 to 4 weeks tops before we're going to go ahead and start this video series. What I'm actually going to do is break down the prototype 1 version, 3D print all of these in carbon fiber, and then what we're going to do is start the video series starting with the frame, and we're going to build that frame, and then what we'll do is go through the entire process of building this reference printer. But Like the C201 design, this reference printer is just that. It is designed so that way you can build a CoreXY 3D printer, understand the mechanics of how it works and how to put one together, but then vary the design for what you specifically want to build. So if you're interested in working on building this printer, make sure you subscribe so that way you don't miss the upcoming series. And please leave comments down there of what you thought was really cool about this printer or things that you might have done differently. I'd love to hear some thoughts of what you think of the teaser video here and what we've built so far. So with that is going to bring the end of this video. If you liked it, make sure you mash that like button. And like I said, don't forget to subscribe so you don't miss one of these videos. If you would like to help support this work of building this printer, please feel free to check out our Patreon, and you can also participate in our Discord. So if you want to contribute to the community as large, we have a Discord that is really an open makerspace. We help all sorts of different makers, 3D printers, CNC, all sorts of different varieties. So it's really open to making as a whole. And that Discord, those links are down there below. So I want to say thank you if you've stuck around this long to watch this entire video. Thank you for watching this, and make sure you check out that C201 video if you haven't checked that out already. It's something that will really be a good primer for building this printer. So with all that said, I want to say thanks again, and we'll see you next time.